minus 15 seconds. T minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Main engine start, 0, and liftoff of the Atlas V with Curiosity, seeking clues to the planetary puzzle about life on Mars.
Program complete.
Here, Curiosity looks the same way that she'll look when she makes it to the surface of Mars and deploys all of her mechanisms.
Not only have we driven the rover, we've moved its arm, put it all through its paces, but it's been in a thermal vacuum chamber and kept very cold. Parts of it have been on through in a centrifuge. We've done drop tests, pull tests, drive tests, load tests, stress tests. Just an amazing amount of testing this vehicle has gone through.
When people look at it, it looks crazy. That's a very natural thing. Sometimes when we look at it, it looks crazy. It is the result of reasoned engineering thought, but it still looks crazy. From the top of the atmosphere down to the surface, it takes us 7 minutes. It takes 14 minutes or so for the signal from the spacecraft to make it to Earth. That's how far Mars is away from us. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Entry, descent, and landing, also known as EDL, is referred to as the 7 minutes of terror because we've got literally 7 minutes to get from the top of the atmosphere to the surface of Mars, going from 13,000 miles an hour to 0 in perfect sequence, perfect choreography, perfect timing, and the computer has to do it all by itself with no help from the ground. If any one thing doesn't work just right, it's game over.
We slam into the atmosphere and develop so much aerodynamic drag. Our heat shield, it heats up and it glows like the surface of the sun. 1,600 degrees.
During entry, the vehicle is not only slowing down violently through the atmosphere, but also we are guiding it like an airplane to be able to land in a very narrow constrained space. This is one of the biggest challenges that we're facing, and one that we had never attempted on Mars.
Mars is actually really hard to slow down because it has just enough atmosphere that you have to deal with it. Otherwise, it will destroy your spacecraft. On the other hand, it doesn't have enough atmosphere to finish the job. We're still going about 1,000 miles an hour. So at that point, we use a parachute.
The parachute is the largest and strongest supersonic parachute that we've ever built to date. It has to be able to withstand 65,000 pounds of force, even though the parachute itself only weighs about 100 pounds.
When it opens up that fast, it's a neck-snapping 9 Gs.
At that point, we have to get that heat shield off. It's like a big lens cap blocking our view of the ground to the radar. The radar has to take just the right altitude and velocity measurements at just the right time, or the rest of the landing sequence won't work.
This big, huge parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we've got to cut it off and then come down in rockets. Once we turn those rocket motors on, if we don't do something, we're just going to smack right back into the parachute. So the first thing we do is make this really radical divert maneuver. We fly off to the side.
Diverting away from the parachute, killing our horizontal velocity and our vertical velocity, getting the rover moving straight up and down so it can look at the surface with its radar and see where we're going to land. And we head straight down to the bottom of a crater, right beside a 6-kilometer high mountain.
We can't get those rocket engines too close to the ground, because if we were to descend propulsively with our engines all the way to the ground, we would essentially create this massive dust cloud. That dust cloud could then go and land on the rover. It could damage mechanisms and it could damage instruments. So the way we solve that problem is by using the sky crane maneuver.
20 meters above the surface, we have to lower the rover below us on a tether that's 21 feet long, and then gently deposit it on its wheels on the surface.
As the rover touches down and is now on the ground, the descent stage is in a collision course with the rover. We must cut the bridle immediately and fly the descent stage to a safe distance from the rover.
Breaking news this morning, and Curiosity is a smashing success. The NASA Mars rover touched down this morning right there on the red planet, a daring mission with more to come.
The landing capped a journey that lasted more than 8 months and covered more than 350 miles. Now the small craft called Curiosity will begin the work of answering some of the biggest mysteries of space. And for the scientists behind the mission, look at that. The landing was a moment of pure joy, a thrilling conclusion to a lot of tension.
Yeah, they had a reason to party, that's for sure.
We are decelerating.
The dramatic landing of NASA's Curiosity rover on Mars last August had millions spellbound worldwide. In the months since, the 6-wheeled mobile laboratory has generated waves of rumors about hints of life-related chemistry on the distant world that, one by one, mission scientists have debunked as they made their findings public. Systematic startup tests of its cameras, sensors, laser, and onboard analytical laboratory were most notable scientifically for what they did not find. So far, they've detected no traces of methane in the Martian air, no unequivocal chemical evidence of water, and no native organic compounds that would indicate that life had left its mark on that world. What they are finding in the 100-mile-wide Gale crater, where the rover landed, is an arid landscape of windswept badlands that in some ways seems hauntingly like Earth. Wheeling across the uneven terrain at 1.5 inches per second, the rover has recorded panoramic vistas that often resemble the Mojave Desert. It spotted rounded pebbles that scientists believe were likely shaped by an ancient fast-flowing stream. Now, after months of trial runs, Curiosity is ready to scratch the surface of Mars, positioning itself this week to drill into the crust of the red planet for the first time. If all goes as planned, mission scientists at the Jet Propulsion Laboratory in California will command the rover's pneumatic drill to penetrate a layer of the region's oldest rocks to collect a pristine mineral sample that might reveal clues to whether conditions on Mars were once hospitable for life. Engineers are finding the $2.5 billion Curiosity rover, the most complex spacecraft ever landed on another planet, more difficult to operate than anticipated. The one-ton vehicle totes 11 instruments, from a sophisticated laboratory to a robotic whisk broom designed to sweep samples clear of the ubiquitous Martian dust. In stops and starts, the rover has traveled a total of 2,312 feet from where it touched down on August 5th and beamed back 18,226 images and nearly 10 gigabytes of raw information. Now, after testing its equipment and fine-tuning its computerized operations, the remote-controlled vehicle is settling down to the serious business of planetary exploration. Next month, it will be embarking on a trek to one of the tallest mountains on Mars.